The first example I have for balancing equations is this one right here. Okay, so it's zinc sulfide and oxygen gas turning into zinc oxide and sulfur dioxide. So this right here is are the reactants, and then right here are the products, and it's like that every single time you have a formula equation and a chemical equation. Okay, and the word equation says zinc sulfide and oxygen gas react to produce zinc oxide and sulfide oxide. Oh, sulfur oxide. And then right here we see that we need 2 of the zinc sulfide, and then we need 3 oxygen gas, and then the products are 2 of the zinc oxide and 2 of the sulfur dioxide. Another example right here, we have vanadium oxide plus vanadium oxide and hydrogen chloride react to produce vanadium oxytrichloride and water. And then right here you see that we need the vanadium oxide is correct. We just need 6 of the hydrogen chloride, and then we need the products are 2 of the vanadium oxytrichloride and water. We need 3 of the waters in order to make sure that it balances each other out. Then we go to example number 3, which states that the word equation states xenon and fluorine combine to produce xenon hexafluoride. So you see, seeing both of them, the xenon is correct. Although we do need 3 fluorine, and then right here, that's what it creates. It only creates 1 xenon hexafluoride. So the fourth one we have right here is potassium nitrate and carbonic acid react to produce potassium carbonate and nitric acid. So as you can see right here, we're gonna need 2 of the potassium nitrates, and then this stays the same, and then right here we just need 1, and in the end we're gonna have to have nitric acid, 2 of the nitric acids instead of 1, just so it can balance each other out from reactants and products, because whenever we have a reactant, or the reactant has to have as many elements and numbers of elements and everything as the products. It always has to be the same. And lastly, we have 5. We have the word equation that says iron sulfide or iron disulfide and oxygen gas combine to produce iron 3 oxide and sulfur dioxide. So right here we see that we need 4 of the iron sulfide in order to balance it out from the reactants to the products. Then we need 11 of the oxygen, and it creates two of the iron 3 oxide and 8 of the sulfur dioxide. So one thing I completely forgot to mention was that whenever we have reactants turning into products, that there are no atoms created or destroyed. It's the same atoms, same elements as before, but it's just combined differently. So here we have example number 6. We have in the word problem that states mercury and ammonium iodine react together to form mercury diiodine, dihydrogen, and ammonium iron 2 sulfate. So let me go ahead and turn it around. Okay. So we see that in the formula equation and the chemical equation, the difference is that we're going to need 2 of the ammonium iodine in the reactant side in order to balance it out in the product side. And then we're going to need, well, we're not going to need anything for the product side because that would balance it out. So now we go to number 7. It says number 7 in the word equation it states that azane and oxygen gas react together to form nitric oxide and water. So in the difference between the formula equation and the chemical equation is that we need 4 of the azane and we need 5 of the oxygen gas in the reactant side. In the product side, we're going to need 4 of the nitric oxide, and we're going to need 6 of the waters. Okay, so let me go ahead and turn it around again. So for number 8, the formula equation says CH4 plus Cl2 turns into CCl4 plus HCl. And then the word equation states that methane and chlorine react to produce tetrachlorine of methane and hydrogen chloride. Chemical equation is the only difference is that we're going to have 4 chlorides, and then later on we're going to need 4 of the hydrogen chloride. Another thing that I will add is that the compounds must never be changed in balancing the equations out. So that goes for the reactant side and the product side. Okay, back to this. We are on number 9. So we have C2H6 plus O2 in the reactant side, and in the product side we have CO2H2O. So in the word equation we have that methane and oxygen gas react to produce carbon dioxide and water. So right here we can see that we're going to need 2 of the carbon and oxygen, we need 2 of the ethane and oxygen, or we need 2 of the ethane and then 7 of the oxygen gas, and then we're going to need 4 of the carbon dioxide and 6 of the water in order to have the equation balance out from the reactants to the product side. Okay, we have number 10 right here. So we have Fe2O3 plus H2SO4, and in the product side we have Fe2 parentheses SO4 3 plus H2O. The word equation states that iron 2 oxide and sulfic acid react to produce iron 3 sulfate and water. So we have here the iron 2 oxide stays the same. We have 3 of the sulfic acid, and then to produce iron 3 sulfate and the water, we're gonna need 3 of the water, so it can balance out from the reactants to the product side. Okay, and number 11, we have right here Fe2O3 plus C, and then it turns into FeCO2. So the word equation states that iron 2 oxide and carbon react to produce iron and carbon dioxide. So we have that we're going to need 2 of the iron 2 oxide, and carbon stays the same. To produce iron stays the same, and then we're going to need 3 of the carbon dioxide. Okay, so there are some clues that you can see in order to see if it's a chemical reaction. First off, the color changes. Then there can also be a solid that forms, or it produces bubbles. It creates fire, or flames, or heat, and stuff like that. So, okay, so we have 12 right here. The formula equation is BaCl2 plus parentheses NH4 2CO3. In the reactants and in the products, we have BaCO3 plus NH4Cl. The word equation states that barium chloride and ammonium carbonate create to produce barium carbonate and ammonium chloride. So we can see right here that the barium chloride stays the same. So does the ammonium carbonate. And then over here we see that the only difference is that we're gonna see 2 ammonium chlorides in the reactant side, or in the product side, not the reactants. The reactants is this, the product is this. Reactant, product. So for number 13, we see the formula is N2O3 plus H2O is HNO2. The word equation states that nitrogen trioxide and water react to produce nitrous acid. We see that the dinitrogen trioxide stays the same, so does the water. The only thing that we need in order to balance it out is that we need to have 2 of the nitrous acid. For number 14, we have H3PO4 HCl in the reactant side. In the product side, we have PCl5 plus H2O. The word equation states that phosphoric acid and hydrogen chloride react to produce phosphorus pentachloride and water. So the phosphoric acid stays the same. We add 5 to the hydrogen chloride, and then in the reactant side, let's see. We see that the phosphorus pentachloride stays the same, and we're going to need 4 of the waters in order to have a balanced out product side and reactant side. Okay, and lastly, we have example number 15. We have the formula equation N2H2 goes in and then it produces NH3. So the word equation states nitrogen and hydrogen react together to produce ammonia. So N2 plus 3H2 produces 2NH3. So the only difference we see here is that we're going to need 2 of the ammonia in order to have a balanced out equation right here. And then also to mention that 2NH3 is ammonia, and it's one of the most common compounds that we have to memorize because it has a special name for itself.